more tight-knit group, it's always better for asking questions. So we will definitely have time afterwards for questions from you guys. So anything you want to ask about scalability. So one thing we all hear is that this has been an everlasting topic, I think, since the beginning of time, or since the beginning of when Ethereum and Bitcoin first went mainnet. I think as far as, first DEF CON Ethereum, there was already a panel talking about scalability. And look at this, 2018, we are here again. So I'm definitely hoping as an investor, this is not Groundhog Day, that we're not going to be back here again next year talking about the same thing. So without further ado, what I wanted to know, obviously, from these guys is not only about what their project does, but also eventually progress, right? We all want to hear execution. What have they been solving in terms of along the line of pushing through mainnet? So let's start first. I know we are all scalability projects, so of course I'm going to get you guys to start introducing the project a little bit, but one condition, no one start with, I am a high throughput next generation blockchain. You have to tell people what exactly is that killer feature you're working on, and why does it make sense for scalability?
I'm Anatoly, so I'm a human, not a blockchain. And we're building a high-performance blockchain. But the main feature is not actually in the consensus layer. It's using a verifiable delay function as the ledger data structure itself, and using the proof of this time generation as a synchronized clock that works before consensus. So once you have a synchronized source of time, you can use all sorts of distributed operating systems optimizations that were written, by smarter people 40 years ago. So that's it.
Hey everyone, my name is Noah Johnson. I'm a PhD student at UC Berkeley and also co-founder and chief product officer of Oasis Labs. So Oasis is building a privacy-first. Is that okay? Privacy-first cloud computing platform on blockchain. So what that means is we're building a smart contract platform, essentially, that protects sensitive data both during storage and during compute. So it protects data even from the workers that are running the smart contracts on that data. Our architecture also allows us to scale to more complex application workloads, including machine learning and data analytics. So our main focus applications are things where you want to benefit from the decentralization of blockchain, but also you want to make sure that you have end-to-end security assurances for what machines are handling sensitive data and making sure that they can't leak that data.
And Mo?
Hi everyone, my name is Mo, and we are not building a high throughput blockchain. So we are actually a layer 2, what people call layer 2, but what we rather call it off-chain scaling project. That is, the goal here is to accelerate every blockchain underlay. That we're kind of a layer on top of blockchain that is having the layer 2 solution to be able to enable more transactions and extremely low latency transactions on existing blockchains. So what is layer 2? Just a quick overview. Layer 2 is basically treating the underlying blockchain not as a processing engine, but treating the underlying blockchain as kind of like a courthouse or a settlement layer. And we optimistically move most of the transactions away from blockchain and into a layer 2 construct. The technology involved, including state channels and side chains, and even interactive computing. So we are leading the research in the generalized state channel area. That is, on our platform, you can send off-chain payment, but you can also run off-chain smart contract pretty quickly. And if you want to try it out, we actually have already released our testnet and also SDK available for build. If you are an Android user, feel free to download our app at get.celer.app. And we also bring a pad. You can try out some fun games that is extremely interactive and built on top of Celer today. So yeah, that's kind of a quick introduction.
And Illia?
Hi, my name is Illia. I'm a co-founder at Near Protocol. We are mobile-first, scalable blockchain. And the idea is that we sharding processing and state, which allows us to actually run the blockchain on mobile devices. This brings both more security, because the more devices you have in the network, you have a Sorry.
It's mobile first.
It's mobile first. It's always phone. The more devices you have, the more security you have. But also, it allows to pretty much bridge the gap between developers and users. So right now, I don't know if you guys using any D apps on your phone. I don't. So that's pretty much like we want to bring users where, like bring blockchain where users are, as well as allow developers to develop directly there without actually interacting with blockchain, like without knowing what transactions and blocks are, but like allow APIs to be very transparent. But it's all powered with sharding.
So we've got sharding, we've got generalized state channels, we've got privacy first, we've got VDFs. Now, we all know we've seen so many scaling projects out there. Nobody is a unique team working on that particular area. Share with us what makes your team's background different that allows us to have the faith and see that you guys are going to be the first to execute and implement the function you just described.
So my background, I spent most of my career at Qualcomm building the phones you guys have in your hands. So I was a core kernel brew developer, which was an operating system that ran on feature phones. Basically, for my 12 years there, every year we had a chip release, so we only had 1 year to write all the code that's ever going to go into the phone, and it had to be done, or it's never going to get shipped. That's where most of my team comes from. We started building this thing in February, and February is almost here, and I think we'll hit that deadline.
So you're shipping?
Yeah.
Before?
Yeah, we have a testnet out. It can do 125,000 transactions per second, steady state, verified up to 150 nodes without falling over. So it's pretty good.
And Noah?
So, right, so one thing that I'm excited about our team is that we actually have a very diverse team that includes academic leaders as well as experienced entrepreneurs and engineers from industry. So the project started at UC Berkeley, out of our research group, our security research group at UC Berkeley. And we proved out some of these ideas through some academic papers that we published, and then spun that off into Oasis Labs to productionize the system. This is, especially with security, and security in an open, permissionless setting, it's a very multidisciplinary problem. So one of the things that is really exciting is that we have people from diverse backgrounds, both on the security side, distributed system, low-level system engineering, and we also have experience actually taking cutting-edge research and bringing it to practice. So this is another big challenge. Is there are a lot of projects that they'll publish some paper and it looks great on paper, it's very elegant, but then the platform itself never sees the light of day, and that's because there are an enormous amount of engineering challenges between kind of a research prototype and actually shipping a system. So myself and our CEO Don actually have transferred research from academia multiple times already. And sort of understand the challenges and the pitfalls. We did this with one of my previous research projects in mobile security. We built a platform for detecting malware for mobile apps, commercial grade platform. That company was acquired by a larger cybersecurity company. And then more recently, we've been, through a collaboration with Uber, building practical systems for enforcing privacy around data analytics. So this requires both new research in the space, as well as an eye towards what are the real-world challenges with an actual deployment, making sure this is usable in practice, making sure it satisfies all the requirements of a real-world deployment. So we're applying the same experience that we've learned from those endeavors to this project. And as a result of that, we've made a substantial amount of progress in actually quite a little time. We published the paper earlier this year. And just a few months ago, we shipped the testnet, and now within, hopefully very soon, we'll actually open up the testnet publicly. So we have some exciting announcements there. So I think that goes to show that when you have a team with diverse background and with experience actually bringing academic research to practice, it really helps in terms of the overall likelihood of being able to actually eventually ship a product, which I think is one of the biggest issues in this space right now. Is a lot of white papers, a lot of theoretical work, and so far we haven't seen a lot of systems actually being shipped yet from that work.
Are you guys open source?
Yeah, we're open source.
Awesome. Which license? Awesome.
Okay, I can hear that the Solana team's going to be working very hard tonight.
Sorry, was that a jab? If it did, it went over my head. Okay.
No, not at all. We're Apache
Yeah, yeah.
2.0.
Okay.
It's great.
Yeah, everything we're doing is open source. By the way, I should mention, one of the initiatives that we're undertaking also is actually an open source design for secure hardware. So this is another critical limitation right now, to the extent that secure hardware is a very, very powerful abstraction for protecting data when you're outsourcing computation. Unfortunately, the only technology that exists for secure hardware right now is proprietary and closed source. And so we have this Keystone initiative that Oasis is working with to actually address that problem and develop a fully open, and by open I mean fully open design. Anyone can audit it, any chip maker can manufacture it, it's amenable to formal verification. We want to sort of solve this problem and open source the entire stack, from the application level down to the platform level, but even down to the hardware level.
Amazing. Mo?
Cool. So everyone's mentioning about team. I will, put team to the end. So first, I think what makes us unique is that we are the leader of the generalized state channel area, and we are the only one that having a mobile SDK where we can develop and run off-chain application. We're the only one, currently in the world. There's no other one can claim that. So we are in the forefront of the research and development of this technology. And at the same time, we are also, coordinating and hosting and organizing this kind of state channel researcher calls. If you guys are on YouTube, feel free to subscribe to that. We have a weekly researcher call that we're kind of helping to form a consortium to build a open standard for the community to use state channel and use layer 2 solutions. So we're also leading that standardization process. It's not like an enforcement, but it's more like an IETF, which suggests the standard, the thing that we're pushing. So I think as kind of like a leader in that space, we can also help to shape a lot of things and do stuff. So another thing that I want to highlight is about our developer communities. Not a lot of project has tons of developer communities, but for us, we have a very tight relationship with top blockchain projects like Ethereum and also Divinity. So from our point of view, this is like a more general point for layer 2 solutions comparing to maybe some layer 1 solutions, is that we can directly tap to existing developer communities. Right? So it's not that you need to throw away all stuff you learn and do something new. It's just like that 20% more, and you can channelize your existing applications and put it into state channel. So that's kind of also a unique thing. And another thing that we have been very focused on education, general education to developers as well. We have been pushing out smart contract development courses, in Chinese language for now, but we will expand it to many other languages as well. We have about 1,500 students graduated from my class. And that is 105,000 students that already know how to code on-chain smart contract. And we are also, after we release the SDK, we're rolling out new courses for them to just take the next 20% step and let them become a Celer developer. So that's also a very powerful thing we have. Now, just jumping back just a little bit on the team, we have, in the founding team, we have 4 PhD founders from UC Berkeley, MIT, Princeton, and UIUC. All of us has many years of industry experiences and also experiences in transforming new technology to actual product and sell it to customers. One unique thing that I want to bring out is 4 founders four founders has a kind of different focus. One of us is focusing on the performance side and optimization of distributed system, and myself is very focused. My whole PhD research and even including my undergrad research is focusing on applying mechanism designs in computer science systems. So basically applying game theory in computer science system. And this turns out to be very crucial in the blockchain system. That is a blockchain system, no matter layer 1, layer 2, is a system with proper incentive design and mechanism designs. So we are also the first one that proposed a working crypto economic model in layer 2 space.
Great. So quick question though. Any researchers can join your call, or are there requirements?
Oh yeah, so if anyone is interested in layer 2, the requirement is basically to contribute. Right, so if if you guys feel like you have the willingness to contribute, and you're definitely welcome to join the lesson.
So they can just come find you.
Yeah, definitely.
Awesome. Illia?
Sure. So our team is coming from two backgrounds. One is we have Alex, my co-founder, who was engineer number 1 at MemSQL, which is a distributed database company, and we have 2 more guys from there. 3 of them actually built all of the clustering, distributed management, distributed sharded transactions for MemSQL, which is right now runs at Uber, at Pinterest, at Goldman Sachs. And then me and 2 more people are coming from Google. I was working at research, but the models we've built are running at Google Search, Google Play, and I also was one of the major contributors to TensorFlow. So I also know how to build a lot of distributed systems. So our team in general is like focused on kind of building this low-level infrastructure so that each kind of individual shard works as well as cross-shard as well as across things. We are actively communicating with all the other sharding solutions. Specifically, as a kind of fun, we are having a panel with Ethereum Foundation and then people who are implementing sharding for Ethereum tomorrow at 9 a.m., which is early, but if you are interested in sharding more detailed, but kind of we actually pushing forefront of sharding research and kind of like what's possible there. And yeah, we believe like bringing the actual industry background of how to build the systems that right now run at actual industry scale to blockchain will propel us to actually deliver scalability.
So what I'm hearing is now we have, if you're interested in second layer, you can call Mo and get on that research group. That's the sharding group, that's the VDF group, here's the hardware group. But I'm going to actually start with Illia on the next question is that one of the things I think Noah mentioned a little bit is why scaling has been challenging is because we always see that the easy route out is always a trade-off with security or decentralization, right? Sharding, we all know, it does exist in historical, traditional databases. Even though it's not easy to implement, it has been implemented. Now, many of the teams we see working on sharding on blockchain, whether it's transaction or state, recently, right? Most of them we see a lot of delays in implementations. Now, can you talk a little bit more about what is your team's approach in terms of the very obvious kind of the lack of security in terms of the single shard issues, especially when you're doing mobile first, with such limited resources on our phones?
Sure. So just for some background, even in regular databases, which are much easier tasks where you don't have any adversaries, you don't have any like mechanics you need to work around for economics, etc. Even there, we still have like very limited number of databases that are sharded and actually work. And the only ones that actually have cross-shard transactions that are like really scalable are one that came from Google, Spanner, like for transactional databases, and Spark SQL, which is notoriously slow. And the problem here is like it's extremely hard to not just like design for mechanics around this, but even just designing the like cross-shard transactions and making sure that you are correctly handling all of the data. Now, some projects have taken shortcuts and decided to not shard some of the concerns, or just kind of put like one of the issues with sharding in general is that you want to shard the state because state grows exponentially, or like at least linearly right now, but as we increase the number of transactions in a sharded system, it will start growing even more. The problem is that sharding states requires you right away to build some kind of locking system. So because you can now change things on one shard before you change things on another shard. And this is where the kind of crypto economics and actually like adversaries come into play, is that what if you have one of the shards being taken over by adversaries? How do you actually analyze things across the shards? So the way we're approaching it, in each shard itself, so first of all, we're trying to make shards as small as possible. And that's where kind of the resources, like limiting resources come into play. But we wanted to have enough, like enough verifiers that will be running in this shard to provide the level of security. But we also, like we have pretty much estimates of what's the probability for different amount of state people can take over each shard. So, and this is where, if you know right now, for example, in Ethereum and Bitcoin, you have kind of finalities that depends on how much money you need to spend to take over, like fork off from the chain and pretty much do a double spend. So the same thing we can provide for every, like for single shard, for multiple shards, and for the whole network. So this allows us to kind of give you the finality depending on what are the transactions in each shard, like what is the value of them, etc. So it is kind of like, you know, it is a balance between security and scalability. The additional thing we have not started working on, but if you think of it, there's a single, running something on a single machine, which is, you know, notoriously not secure, but is fully scalable, right? You can run a lot of things on different machines. And you have everybody in the network runs the same thing. So this is your spectrum of security and scalability. So right now we kind of have two modes. We either run on AWS, which is not secure, but super scalable, or we run on Ethereum, which is super secure, but not scalable. But with sharding solution, you can actually have kind of select what you are interested in on the spectrum, right? You can say, well, I'm willing to pay this much for running in 2 shards. I'm willing to pay this much for running in 1 shard, on 1 machine, on 10 machines, etc. So what we wanted to achieve is this ability for a developer to specify for each specific kind of computation or operation, what is the price they're willing to pay for security. So to kind of have the spectrum between security and scalability at the developer's hands.
Very interesting. I can't wait to see the actual testnet and mainnet. Now, jumping around a little bit, right, to you, Anatoly, even though we are using VDFs in Solana, you are still using proof of stake for the generator selection. So it's still a leader-based consensus mechanism. How are you looking at preventing against DDoS attacks? And in terms of, can a botnet simply follow the leader around and generate these DDoS attacks?
Sure. So the interesting question there is,
and especially the fact that now shorting of digital assets is becoming
Yep.
more easily, more easier.
the question there is, how do you, if you know who the next generator is, and this is a problem with kind of, you know, in Bitcoin, if you're familiar with proof of work, when you win the puzzle, it's a random event that no one can predict. And that's when you get to encode the block. And that kind of prevents, it's a way to prevent some form of denial of service attacks. What's interesting in proof of stake systems, your identity isn't a particular machine, it's a private key. And you can't really DOS a private key because it can really transmit from anywhere in the world, from any machine. And all it needs to do is send an asynchronous message to the network. So if that message is received, then it's not DDoSed. And there's no way for you to really know where that message is going to come from. So there's a lot of fairly simple ways to work around problems like that.
But you do need to send transactions to somebody, right?
Sure, but that thing that you're sending to, you have no idea if that's actually where the next generator is going to transmit from.
So you have like a proxy set up?
Potentially, yeah. The real like blood, sweat, and tears engineering is just doing QoS based on stake weight with a bunch of net filter rules.
I see a lot of smiles and
Yeah.
head nods. Alongside DDoS, right, what about state channels? Is it possible to have DDoS directed at your state guardians, or is it not a big issue?
Maybe I should tell a little bit like what State Guardian is doing. So State Guardian is this crypto economic construct we proposed to watch your state for you when you're not online. So in the early days of state channel research, there's this unrealistic assumption that is, if you're in a state channel, you gotta be online all the time, because if you go offline, your counterparty may dispute this channel with the older state that is not the most recent state. So we introduced this State Guardian with many benefits like lower liquidity lock, uniform interface, and a very novel or new way of like the pricing of the State Guardian work. But essentially what the State Guardian network is doing is that it is a sidechain. right? So this is another thing that we are kind of moving towards. That is, all the layer 2 solutions are kind of going to combine together. Is our view that you have the most optimistic layer of a state channel, and if the state channel sometimes needs some help, you may introduce a sidechain to help that layer. And then finally, if everything fails, you revert to the root chain. So this is kind of a 3-tier architecture. Now, for the state guardian sidechain itself, the DDoS attack is going to be having the same effect of the DDoS, like the block proposer, basically. So you can still submit your state to the state guardian sidechain to any kind of a proposer or participant in the sidechain. Again, it's hard to DDoS a private key, basically.
So can I ask a question? So I've heard one criticism of state channels in these approaches is that it, to some extent, maybe sacrifices decentralization a little bit, because ultimately someone needs to operate the infrastructure and the nodes that are running the state channels. And if those fail, then it seems like you have, again, a single point of failure, which undermines the purpose of decentralization.
I think there's no inherent requirement of centralization in the sense that you can connect it to any state channel service provider you want. And the real centralization comes from what I think, again, on the crypto economic side, actually. So in the state channel, if you are a off-chain service provider, you would have to have a lot of money to be able to deposit to each of your users. Right? So if you're opening a channel with your user and hoping to relay a transaction, let's say in the simplest form payment to your end users, you're gonna have some money deposited to that channel beforehand. So that creates a liquidity challenge for this off-chain service provider, that they need to solicit enough liquidity to open these channels. And that indeed creates a centralization risk. And that's why we're introducing something called the liquidity backing auction and a proof of liquidity commitment mining process to mitigate that as well. I'm actually giving a talk about these crypto economic construct in CESC tomorrow. If you guys are wrong, definitely stop by my talk.
Well, I get that you're getting very good at making sure there's a segue to every event you're going to be at. Which is important. You got to get your project known. But anyway, but Noah, back to you, right? You asked Mo some questions about state channels, but something that I'm actually very curious about is on these trusted hardware enclaves. At the moment, a lot of the execution of the smart contracts, because it is private, the only attestation currently you have to rely on, SGX have to rely on Intel attestation services. What's your viewpoint in terms of how does that impact your development timeframe? Because you do talk about open sourcing it, but we all know hardware development takes a long time. But in the meantime, what are you going to do? How are you going to sort of look at this as, are we back to centralizing the verification of all these executions back to one party, Intel?
Sure. So to be clear, what Intel provides is just the facilities for verifying that a given chip that is running a computation is a genuine chip that Intel produced. They don't control the keys that allow them to extract the data when that computation is running on Oasis. The other point that you made is actually a good one, which is, in this design, yes, ultimately, Intel needs to be the one to certify that a machine is eligible to run a computation if that computation requires SGX. That's exactly the reason that we're spearheading this initiative for a more open design and a more federated attestation service that can be more decentralized. Our philosophy with Oasis actually is not to be overly opinionated about any one technology, but rather to recognize that there are a host of different technologies for providing secure computing. Each one have different trade-offs, each one require, to some extent, trusting different actors. If you're running on any hardware, you trust the manufacturing process, right? We saw a few weeks ago that there were reports that China was putting backdoor chips on the hardware, right? So anytime you're running any of these systems, you're trusting the hardware, right? Implicitly. That's usually not modeled in the threat model for these crypto economic analyses, but that is something to keep in mind. What we want to do is say, okay, well, secure hardware and secure enclaves specifically provide a very powerful primitive for securing data on remote machines. Right now, the state-of-the-art for secure hardware happens to be called SGX. It's developed by Intel. Oasis isn't designed specifically for SGX. It's designed to make all of these different technologies accessible to developers and let developers to decide which ones they want to use. For certain applications, for certain threat models, maybe the developer is fine using SGX. For other threat models, maybe they want to insist that their computation only runs on Keystone. Or maybe they don't want to trust hardware at all. Maybe that hardware-based attacks are part of their explicit threat model, and they instead want to rely on cryptographic techniques like multi-party computation and zero-knowledge proofs to keep the data secret. So what we're building at Oasis is actually a design that can integrate all these different technologies together, and with the same interface allow the developer to specify what secure computing model they want to use, and essentially the platform handles all the details. So if they want to use secure hardware, great. If they would instead, if they're willing to pay the penalty, the performance penalty for using, multi-party computation or homomorphic encryption, that will also be handled transparently for them, and it's just a configuration flag.
Awesome. So
Yeah, the question I had was, how does Oasis deals with like scalability when you need to touch the same state, for example, from two different contracts, or two different executions need to change the same state?
Right, so we have a scheduler essentially that when the transaction is submitted, it can see which portions of the state are accessed and then schedule those transactions, essentially batch them together and run them on the same group of workers so that there's data locality when those transactions execute. So one thing I didn't have a chance to mention is the overall architecture of Oasis. The key behind our scalability, in particular scalability for complex computations, is separating execution from consensus. So if you think about the two functions that are required for a distributed smart contract platform, there's some machines that need to run the computation, right? Physical compute resources. And then there's some portion of the network that is responsible for maintaining the ledger and deciding what is the authoritative history, right, of all transactions and all of the state. Conceptually, those are very different things. They happen to be bundled together in today's architectures mainly because Ethereum evolved out of Bitcoin, where Bitcoin was the first to propose this architecture where you have each miner is independently processing transactions and deciding which ones are valid. And Ethereum extended the functionality of Bitcoin with the ability to run computations rather than just payments, but it inherited the same design limitations. So what we're doing is taking a step back and recognizing that actually those things needn't necessarily be coupled together. So when you separate those things out, the execution from the consensus, what it allows you to do essentially is optimize those things independently. So right now in Ethereum, the reason we have these performance issues, the reason we have this congestion is because consensus is the bottleneck. And the reason consensus is the bottleneck is not because consensus is inherently expensive, but because the nodes right now in Ethereum have to rerun the entire transaction in order to validate it. So by doing this separation, you can bring in new techniques in verifiable computing that essentially allow the consensus nodes to verify that the computation result is correct without actually having to run the computation. So you can use much more lightweight consensus algorithms and essentially take consensus off of the critical path. The other advantage of this is, again, you can scale these layers independently. So if the computation becomes the bottleneck, it's very easy to spin up a worker that just is responsible for offloading some of the computation. If the consensus is the bottleneck, it's very easy to add another worker. By doing this decoupling, it provides a lot more flexibility to optimize and scale out these layers independently. And you can't do that in Ethereum. Right now on Ethereum and most existing architectures, including simple sharding-based approaches, which essentially just partition the network but have fundamentally the same architecture within each shard. The problem with that is that if you add a new worker, you're not actually increasing the horsepower, the capacity of the network. The only thing you're doing is adding another worker to repeat exactly the same computations that all the other workers are running. So that buys you additional security, right? But it comes at a cost that you don't have the ability to very seamlessly and elastically scale out the performance of each of these different functions in the network.
What if those workers are really fast?
Sorry, say that again?
What if those workers are really fast?
What if the workers are really fast, then so what?
Then
Solana.
you're not bothered.
So you mean if hypothetically if they were all running high-end GPUs and
cheaply available hardware that you can buy as a gamer at price?
Right, so the issue with that is in a heterogeneous environment, which I think is a more realistic model for essentially a truly decentralized blockchain platform, then any architecture that doesn't have this ability to scale out the workers is going to be vulnerable to the straggler problem, where a slow machine essentially is going to slow down computations for all the other machines. Any voting-based system essentially will have this property. So you can make an assumption that, oh, everyone is just really fast. But what you're also assuming actually is everyone is equally fast, because all it takes is one slow worker in that supermajority group to slow down and cause congestion for the entire computation.
Well, it's just congestion and finality, but not actually slowing down computation. The rest of the network can continue.
Sure, but finality, I mean, if you don't have finality, then the fact that you finish the computation, that doesn't matter. Because to the end user, what matters more is that the transaction has been confirmed to the ledger.
Sure, but on average, they all kind of execute about the same rate, given the same hardware. Like it sounds like when you offload to heterogeneous compute, like it sounds to me like you guys are building a state channel.
So, there's, yeah, I mean, there's a great point and point of clarification. So, state channels are very useful for certain applications, especially those requiring low latency, because you can do most of the work off-chain and only need to appeal, to the root chain, when there's malicious behavior or when something goes wrong. So that's very useful for, payment channels where you're sending a lot of payments and you don't necessarily need to have each one recorded to the root chain. You just want to checkpoint them periodically.
And also opt-in smart contract.
Sure. The issue is that, again, we're focused on supporting fundamentally more complex workloads. State channels are ill-suited for scaling in that way because fundamentally the compute capacity of the state channel is still limited by the resources of the root chain because you always need to be able to appeal back to the root chain if something goes wrong. So if you imagine trying to run a really, really complex machine learning algorithm through a state channel, if a worker misbehaves, the state channel needs to be able to submit a fraud proof or appeal to a judge contract on the root chain. And in order to adjudicate that sort of transaction, the root chain needs the ability to run the same computation. So you have this circular problem then if you're trying to use a state channel to run something complex, if something goes wrong, you need the ability to run something equally complex on the root chain. So this rules out applications like, for example, games, where if the cost of verifying this fraud proof is higher than the stakes, then the economics just don't work out. If you're trying to build a poker game with a state channel and to appeal misbehavior on the root chain costs $10 and the hand that you're playing costs $5, then essentially an adversary can misbehave and force you to lose money by correcting the misbehavior. So state channels are really useful for games where you need low latency and a high number of transactions, not all of which need to be persisted to the blockchain. What we're focused on is longer running, more complex computations where the objective is not high transactions per second, but rather the ability to run fundamentally more complex transactions. And that needs a solution, a layer 1 solution, essentially because to do that efficiently requires that the consensus algorithm itself can efficiently verify computation results. For all the reasons I mentioned earlier, where the consensus, in order to decide whether a transaction should be allowed on the ledger, it needs to somehow know that the state transaction that's represented by, the state transition that's represented by that transaction is valid.
But when computing that proof will be more expensive than the computation itself. Like if you're doing machine learning load and you need to compute a ZK snark to prove that computation is correct, for consensus to not redo the same work, the ZK snark will be more expensive than actually running gradient algorithm.
So it depends on the application workload. This is exactly the point of using verifiable computing, is that any verifiable computing technique, by definition, is able to verify that a result is correct without rerunning it. Depending on the application workload and the specific technique that's used, if you want to use zero-knowledge proofs for this, there are ways of building zero-knowledge proofs, depending on the application workload, that are much more efficient to verify than they are to execute. Independent from that, the protocol actually can still run a given computation on multiple workers and use a voting-based scheme to determine if any of those workers is lying about the results without actually having to run the computation.
Bringing back the computation to the consensus.
Hey guys,
no, it's not running computation. It's running a protocol that schedules jobs to run on workers and then ensures that all the workers agree about the results. And all you need to do is check that the results are consistent. You don't need to rerun the computation. And if you have a network where you have staked participants and you're randomly selecting nodes to run, then even if an adversary controls one machine and says, I'm going to run this transaction and the result is 3 even though the result is 4, this protocol would detect that without actually having to rerun the computation, just by seeing that, for example, 99% of the workers said the result is 4, this one guy said it's 3, it's trivial to know that that guy's lying and this slash has gone.
But you can use any layer 1 for that. in the
Hey guys,
contract, right?
I'm loving this because this is my first time ever calling a timeout.
Right.
And the reasoning is that I think every
See why
time.
I'm being quiet? because I'm friends with all of them.
But I think a lot of you guys who have gone through a lot of these sessions, you all feel like every time you hear all these arguments is why you get very excited about the field. But let's pull back the curtains, right? We're not here to just listen to theoretically what should happen. Let's see, I want to know where you guys are at today in terms of execution, testnet. If it's testnet, what is testnet to you? Like, number of nodes, what transactions are you going through? If not testnet yet, what else, where are you at? And then second question is, then the last 4 weeks, what have been keeping you guys up at night? Or your team up at night?
Sure, I can start. So we've been open source from day one, so you can consider the first line of code a testnet, but it's been multi-node since June. So we've done a bunch of performance optimizations. You can, it's not BFT right now, it's totally insecure. There's a bunch of holes in the protocols, but you can statically link smart contracts run in Rust, and you can run a high performance blockchain up to 150 nodes that can do 125,000 transactions per second. So you could potentially play interactive games without even knowing that they're hosted on chain. So that's what it is. I mean,
and what keeps you up at night these days? What are the next problems that you're trying to solve?
The stuff that keeps me up at night is some of the work that Oasis is doing, simply because, not because I see them as a competitor, but
so you're dreaming of Oasis.
SGX at a station. This stuff is all nice and great on paper, but to actually implement it is a lot of work. It's blood, sweat, and tears. And security is a big problem in any proof of stake system because ultimately you have a private key that signs transactions, and most of these systems have a slashing condition. So if this thing is running a virtual machine, like the virtual machines we're building, all these virtual machines have 0 days, and this thing gets hosed, all those keys will get slashed, and that's how all these networks will go down next year. So SGX is one way to sandbox some of this stuff. So this is what's been keeping me up at night, because ultimately we have to deploy a live system, so we have to secure it for people who are running it.
Oasis?
Sure.
Sleeping well?
So Ryan, I think I mentioned earlier we launched our testnet a few months ago. It's a private testnet. We're slowly onboarding, as many developers as we can, making sure that the system is robust and stable and high performance for the sorts of applications that developers are building. So we're very excited about that. Again, most of the time is, at least on the engineering side, is spent, fixing bugs, improving the performance of the system, and building out some of the other pieces of the testnet, including, Byzantine fault tolerance, all of which are necessary for eventually launching a mainnet.
And you mentioned a private testnet. How do people get on that?
So they can go to, thank you for asking. They can go to oasislabs.com/developers, and they can fill out a form and tell us what they want to build, and we'll send them instructions for accessing the testnet as soon as we're able to support their use case, which is looking very soon.
If you want to expedite, just say, Noah, I love your talk today. Just joking.
If you guys are testing it, effectively all the code is on GitHub, so go to our GitHub. You can download the code, compile some Rust, and if you hack it, we'll give you a t-shirt. There's some very easy ways to do that.
So Mo, we already know, you mentioned you're already in testnet, but I want to know what's keeping your team up late at night these days working on.
Yeah, so first of all, about the t-shirt thing. If you're developing on our platform, we're definitely got the most awesome t-shirt around. Okay. Yeah, just kidding. So what's keeping me up at night? So literally, it's because of we have been working so hard trying to figure out launch the testnet and SDK and also the user product. You guys can all try. So this is probably one of the cases that it's not a black window of testnet, and you don't need to compile anything. You just download a Android app and you try our testnet. So this is also something that's pretty cool. So what's keeping me up at night is actually something not quite related to my project. Figuratively, keeping me
Is
up.
Oasis again?
Fortunately not. I mean, something, the thing that keeping me up at night is about, I have been thinking about what is the, business model, a viable business model for blockchain application to actually run, right? So, we have
It's not SEO.
Well, look at that.
Right. Right, so that tells us that's probably not the right way, right? So for example, like I have been talking with, but I have a lot of friends in like the game industry, right? So they have been building games for 10 years, 20 years, and they are looking at jumping into the blockchain bandwagon. What they have been accustomed to and familiar with in terms of business model is that they're selling stuff in their game. They're selling in-app purchases. That's their core business model. That's how they make money, right? So one day I was like pitching to my friend and saying that, okay, look, you have this awesome Celer SDK. You can build super interactive game, and you can do all these cool things. And most importantly, you expand your user base so much that you cannot imagine, right? So you expand your user base beyond the financial boundaries. This is the kind of thing that no one have ever imagined. But his question to me is that, okay, dude, tell me how I make money, right? So I think the thing that we should also think about as platform builders is not only build a platform and have a super awesome scalability solution so everyone can build stuff, but also help, because we are at the forefront of solving the scalability challenge and making these things useful. And it might also be our task to figure out what are the actual business cases. What are the business cases or business model that can be built on top of these things? So that's kind of like the thing that I've been thinking recently.
So, Illia?
Yeah, so we're a much newer project, I guess. So we're only 2 months in.
So sleeping very well.
Yeah. Well, not really, but so yeah, we have a prototype which we pretty much developed really quickly to pretty much. It seems like everybody in this area writes a white paper where they put a lot of assumptions and then they start building and then realize that that doesn't actually work. So we decided to go it the other way, where we build a prototype first, we prove all of the assumptions, which we disproved half of what we actually thought is true, from like what consensus algorithms would work to how cross-chart should work, etc. So we have this prototype that we're benchmarking right now, and we're planning to have testnet somewhere by end of the year.
I know this has been running a little bit longer, so I'm aware of everybody's attention span. I'm going to open up to the floor, but I'm going to take 3 questions, and then you will have time to ask the teams afterwards directly also over a beer, over wine. Yes, over there.
Since this has been keeping you up at night, what business use cases do you think would be best for Celer Network and for the blockchain industry as a whole?
So the question is best use case for Celer Network.
I mean, for Celer, okay, I think this question is also open for everyone. Right? So for us, I have been keep thinking about game, right? So I cannot get over with game, basically. The reason that I have been thinking about game is game itself is an incentive for people to join and play, right? So if we're talking about the bread and butter, I think finally the bread and butter of cryptocurrency is going to be tied to the payment industry. It's going to be that. But maybe it's not the right time yet, because there are so many different competitive products there. Like if I go back to China, I never use cash, I just use WeChat. WeChat is like the best micropayment solution out there. But for game, as I mentioned, it indeed opens up the, especially game involved with financial transactions. Say you and someone else you don't even know can play a game of chess and betting on each other, like basically money. This is something that is just simply not possible and fun. And because of the fun part of this application, it creates an inherent incentive for people to participate. So this may be a very good entryway to like this entire blockchain technology, as long as we can provide the user experience similar to the game that people have been experiencing these days. So that's why that's where we can help. Like we can help on the interactiveness and the user experience side of things. So.
So I fully agree. I also think games will be one of the killer apps and the Trojan horse into mainstream. I happen, maybe not surprisingly, to think that Oasis is is an ideal platform for, especially competitive.
The next rule is going to be you guys answer the question without naming your project.
But starting next question. Okay. So the reason for that, of course, is because most game logic is complex. We saw this with CryptoKitties. CryptoKitties technically is actually quite simple, but even CryptoKitties on Ethereum, caused major congestion and it caused, drove users away because they got frustrated with the high gas.
It would be totally fine in Solana.
Sure, I just need to go down to Fry's and buy a high-end GPU.
Just like every Ethereum miner.
So the other aspect of games, for Oasis, we talk about privacy first, and usually the focus is on protecting sensitive user data, right? Privacy first also means confidential data that may not be private, but for the application to be successful and practical, you need to be able to keep the data secret from both players and miners. And so a good example is a poker game, right? If you were to build a poker game on a state channel, then the node that's running the poker game could trivially look at the deck and cheat at the game. Whereas if you're running that on Oasis, the same privacy guarantees that would protect sensitive data. Wait, this is the same answer from before. Those same properties essentially would ensure fairness because it means that not even the miner that is running the game would be able to view the secret state of the game and cheat. So the reason, so that's useful for games where you need secret state. There are a bevy of games for which you don't need secret state that maybe state channels make sense. Like chess is a good example where all of the state is public. Tic-tac-toe is another one. There's a reason these are the sort of the go-to demo apps for those sorts of technologies, is because those things don't actually require confidentiality.
So what I'm hearing is that this is an awesome, interesting topic. So make sure you guys grab them over a beer to continue the game side.
Right.
But one thing I can say is on the gaming side, if you guys have, or any of you are game developers, the gaming developers are the first batch of people that once you explain blockchain, they get it right away. Because they've been so entrenched in the incentive development for the games, because it's basically addiction, right? They have been designing for years about getting people addicted and how to keep people, humans like us. So anyways, I'm going to park this question so that we can get to the next, but this one.
Sure. Just a technical clarification. We can do pokers, and there are off-chain protocols you can do random shuffles and stuff like that.
Cool. Second question? Nobody? Okay, cool. So actually, no questions, then I'm going to ask one last question. Because as much as we love blockchain, I want a proof of human. So when you're really stressed out, do you do anything besides thinking about blockchain?
So I'm a world-class athlete in the sport of underwater hockey. So at one point in my life, I represented the United States in an international tournament. So what I do is I hold my breath and play the sport until it feels like I'm drowning. And at that moment, I don't think about anything else except that I feel like I'm drowning. And then I feel great.
Noah?
The
You're not human.
I'm definitely human. So I dream about Oasis, just like my friend.
It's all encrypted, so we don't know.
I used to have more of a social life. One thing I enjoyed doing before working on Oasis was I've been playing classical piano for 10 years. And I've taken a little break from that to focus on the project, but they used to help relieve stress, and I would love to get back into that.
If blockchain doesn't work out, we'll see you in a concert. And Mo?
Well, I like movies. I watch movies and then make some movie as well. So,
Well, what kind of movies?
it's it's normal movie. It's not like some cult like a crypto movie.
And Illia?
I read science fiction. A lot of it.
Ready Player One?
Sure.
So anyways, well, thank you guys for coming. This event is actually the finale of a series of scalability-related topics that 500 has been curating. And if you guys are interested, we actually started about a month ago with a podcast series called 500 Block Crunch with the help of Jason. Jason, where you are. Awesome curator for content. So if you want to know a little bit more in depth, a lot of the basic backgrounds of some of these projects, do go to the podcast. I believe, Jason, where is it available on?
Anywhere you listen to a podcast on. So
Awesome.
Spotify, Stitcher, iTunes, whatever.
So anywhere you usually listen to your podcast.